to talk really loud. Thank you for the introduction. Hi, everyone. My name's Kevin. Today I'm going to be talking about Robrix, which is a complex app that runs on multi. We okay? Okay. Sorry. I'm going to be talking about an app we've been working on for a while as part of an endeavor to push forward the state of the art in Rust application development. So what is Robrix? It consists of a single code base, entirely in Rust, just one language, and it runs seamlessly on many different platforms. So here are some screenshots. Oh no. It was just working. Okay. Okay. It looks a little bit stretched out. I don't know. Okay. Anyway, sorry about that. Right, as I was saying, we have a single code base purely in Rust, and it runs seamlessly on many platforms without requiring a single line of non-Rust or platform-specific code. Basically, the one takeaway I want you to leave this talk with is that you can now build complex apps, like real-world applications, entirely in Rust. You don't have to go to other languages. Specifically in this case, Robrix is built on a strong foundation of Makepad plus Project Robius. So Makepad is a UI toolkit that you may have heard of. They're currently doing a workshop right now, actually, in the basement. So after this talk, you could go check it out if you want more detail. It's a high-performance GPU-based UI toolkit that offers hot reload and really easy, really customizable styling of the UI based on shaders. And then Project Robius is kind of a set of abstractions of platform features, OS services, and also build tooling and a whole bunch of other things that are needed to round out the application development experience beyond just drawing a UI. So let me talk about the background and the motivation for this project a little bit. So what is Makepad at a glance? As I said already, it's a high-performance UI framework. We have a nice little DSL, which I'll show you some examples of for declaring the UI and styling it and showing how it should work. It's very lightweight and very efficient. You can build the entire Makepad UI stack within around 10 to 15 seconds, depending on your computer's power. And it supports many different platforms. So I'll show Robrix on iOS and Android, Mac, Windows, and Linux. And then other platforms that are sort of in progress are WebAssembly via Wasm, MetaQuest for VR, and even things like OpenHarmony. So then at a glance, what is Project Robius? So that's, like I said, everything else that we need for app dev beyond just drawing a UI. So another goal of Project Robius is to make mobile sort of a first-class concern in the Rust community. Oh, can we fix this? This is very distracting. Let me try to fiddle with the connector here. Okay. So the goal of Project Robius and Makepad together is to bring front-end developers into the Rust ecosystem and then also bring the world of app development to existing Rust stations. So the idea is that developers would be able to leverage the robust, safe, and high-performance ecosystem that Rust offers. They never have to deal with multiple different languages or environments, like FFI bridges to something like Qt, and they never need to write a single layer of platform-specific code. So Makepad very recently released their 1.0 version earlier in May that coincided with Rust Week 2025. It's been under development for over 5 years, and the need for more than just UI development, UI drawing in order to make an app, fostered a joint collaboration between us and them. So both of these projects are fully open source, decentralized, and community driven. Everything, like I said already, is fully written entirely in Rust, and with the goal of supporting Rust developers, we directly use the native platform APIs in a lightweight fashion, and there's no heavy dependencies like an underlying web engine or bridges to other UI frameworks. So specifically for this audience, you guys may not be familiar with Matrix, so let me explain a little bit about what Matrix is. It's an open network for secure decentralized communication that's pulled straight from their homepage. And I think you can best think of this as something similar to like Ding Talk, Microsoft Teams, Discord, or Slack, but it's an open and federated version, so similar to something like that. Why did we choose Matrix? Well, we needed a killer application to drive the development of our UI components and our Project Robius app development toolkit components. And we were trying to brainstorm, what is the most demanding app of the underlying platform and of the UI. And a good example of this is a modern chat client, right? it needs a whole bunch of things, as you can see here, from the underlying platform in order to give you that deep sense of integration with your platform. And then why do we pick Matrix? Well, like us, and like Makepad and all of our projects, it's open source, decentralized, and recently focused on Rust. So they're writing the newest generation of the Matrix SDK in Rust. So that works well for us. All right, so back to Robius and Robrix. So how do we take these two components and fit them together? So this is sort of, is there any way we can fix this, fix this flickering? It's quite distracting. Hold on, let me try to disconnect and reconnect. Right, so as you can see towards the middle left side, Makepad or the UI toolkit of choice, doesn't have to be Makepad, and the Robius platform abstractions sit in the middle underneath the application logic, the UI, the UX, and the business logic, and then they talk to the underlying platform. I don't need to go into too much detail about this, but for a real app like Robrix, this is how it looks. We have quite a lot of application logic and you know, a select subset of the platform abstractions. I don't know if you can see that in the bottom left here, bottom right. And basically, like I said, this is, you know, a lot of details here. It just goes to say that we want to show the, oh no, we want to show that a really complex and many fully featured app can be written in Rust with this actual framework in real life. Okay, so let me give a quick demo. So can we, oh, we can't see that. Oh, that's irritating. Oh, I think I'm going to have to quit the presentation. Okay, great. So this is Robrix. It's currently just a matrix chat application. Oh dear, I'm so sorry for this. And you get really high performance. We can scroll easily exceeding 120 FPS. This is only a 90 hertz screen. I'm not sure what you'll see here. We're able to offer a lot of unique interactions. One thing we can do is very, very performant dynamic resizing. So let me show you here. And we have this sort of adaptive view that allows you to, in a single code base again, here, let me move it to the other side. Resize to fit myriad different screen sizes. So this is what you would see on a mobile device. And here's the same thing running in an iOS simulator. Right, this is a different account, but we have kind of all the interaction paradigms that you would like, all of the platform integrations that you would like accessing location, files, proper usage of cache and everything like that. So that's macOS and Android, and then here's the same thing running on my foldable phone. You can get that nice little desktop view also on, sorry, I don't have enough hands, on the tablet with the dockable UI here. So one thing that really bothered me about many chat clients is when you have a lot of screen real estate, you don't, sorry, I don't have enough hands. You don't effectively utilize the white space. So one of the first things we did was allow you to sort of treat Robrix like an IDE, and you can add all sorts of custom panes. So we have this nice dockable tab UI, which Makepad supports natively. And you can see we have very high performance and a lot of different interactions. So jumping to messages, these sort of sliding panes. We can do things like custom context menus, right? Lots of different things, a basic settings pane, nothing too interesting there. And all the sort of stuff that you would expect from a real usable app. So I don't think this is particularly impressive, but again, this is entirely in Rust, and there's no platform-specific code. And you get that kind of high-end feel, the sleek, high-performance feel, basically for free. Okay. All right. So I just spun out a new release of Robrix on our GitHub page, which I'll show at the end, so you can download it and try it out for yourself. It's not perfect yet. There are some rough edges here and there, but it's generally usable for daily life. Okay, so let's take a look at some of the code that Robrix implements. First off, I'll give you an idea of what Makepad and Makepad's app code actually looks like, how to define the UI with their custom live DSL, and how to connect that UI to the Rust logic, how we leverage Rust for safe high performance, and how we can utilize some of the Robius crates for deeper platform integration. So this is what the code for defining, or rather declaring, the UI for a message looks like. So this is significantly shortened to remove some of the details, but basically this block of code corresponds to this visual element on the right side here. So I can give you just one quick example. So For messages that are in reply to another message, you would see here, this would be made visible. I don't know if you can see my cursor here. Yeah, you can. Okay. So this visible would be set by true. By default, it's not there by the Rust code. And that corresponds to this sort of top section that gives you a preview of the message that this message is in reply to. So let's scroll down a little bit and look at the body of the message. So the body itself corresponds to everything that is just within this message's bounds, the contents of this message. And if you want to look at the Makepad code in a little bit more detail, basically width, I think, is quite self-explanatory. You want to fill the horizontal bounds, and you want the height to be set to the oh dear. Okay, let's just move on. And then you basically compose many different custom views or other widgets into a single larger widget. So if I wanted to have a little sub-view that contains our profile information, like my user avatar, the timestamp of the message, and whether or not it has been edited, right? I can have that here. And you can arbitrarily compose these views too. Is there any way we can fix this? Okay. And then for the message content itself, currently it just consists of a label for the username, the message, which can be plain text or rich HTML, or other things that I'll show in a moment. And then at the bottom we have things like the reaction list and the list of avatars of the users who have seen this message, right? So we can take all of these different custom views, we can define them inline, or we can abstract them out into separate definitions in different files, much like Rust's module system. And we can compose them and interleave them in and amongst each other. So if you take a look at this room screen, right, which is just the view of one screen that I showed before, we have the room screen is the outer widget in green. Then the timeline, which is sort of an infinite scrolling viewport called a portal list. Okay, this is killing me. And then each one of the elements in the portal list can be one of many different things. So maybe just a small event to describe who joined the room or whatnot, a day divider to show you when a different day has elapsed, and then different forms of the message widget, which I'll show in a second, the reply preview, which you saw already, all these other details. And then at the very bottom, a bar for inputting message content or attachments or your location into the room. So how do we avoid a lot of the pitfalls in Rust around the lack of inheritance, right? So the Makepad DSL does support direct prototypical inheritance, which makes it really easy to extend and customize your widgets, or just restyle them if you want a slightly different modified version of one widget in a different context. So here I have two examples of the message widget being restyled or extended. So you'll see the syntax here. In the upper left, in the angle brackets, message is basically saying I'm defining a new widget called image message, which is a message, right? It inherits from message. And all I need to do is just change the body of it, the content, to have, instead of a text body, we'll have an image body, right? So nothing particularly revolutionary there, but that's all we need to do. We don't need to redefine an entirely new widget from scratch. And the same thing if I wanted to have a smaller, more condensed message. For example, if you send a bunch of messages all within a short time frame, you don't want to show the profile every time because it wastes vertical space. So here we have the same thing, where I've basically just removed the profile, or I've changed the profile and the content to reduce the visual overload of the widget. Okay, so then now that we've defined this UI DSL, how do we actually do something with it? How do I, handle a button press, for example? So in this case, so picture on the upper left is the room input bar, which I showed before. It has a button for the location. It has a message input, a text input, where you can type text to be sent, and then it has a send message button, right? So you can see I have a little bit of styling here. I don't need to put that here. This is abbreviated, but I can also have that be in the default widget definition if you don't want to override it every time, or if you don't need to set it and everybody has the same format, for example. So then in the Rust code, we have a structure. So that's what this double curly brace means over here for the room input bar. There is a Rust structure that is defined with the same name, not shown here. And then we have some different traits from the Makepad system, in this case, widget. And I'm implementing the handle event trait. So events are basically, it can be anything like incoming packets, incoming socket messages, mouse messages, interactions, touch with the screen, or any kind of other custom action. In this case, basically, when we go to click on the button, right, this little send message, an action will be emitted by that button. It handles the click directly, and then we can handle that action in the parent widget of that button. So what we do is we do a little query. So you'll see we have if self.button, and then we have a live DSL ID, right, which is the green highlight there. If that's been clicked, or if the message input was focused and we hit the return key, then we'll go ahead and send that message. Now, this brings me to the next part of dealing with complex UI and UX behavior. How do we actually send that message? I don't want to do that on the main thread. Our golden rule is to remove as much logic from running on the main thread and move it towards to background tasks or background threads. So what I have here is a little, just a basic channel that informs an async worker task in the background that I'm ready to send a message. So that's this little part here, submit an async request. So I take the UI state, that was obtained from these widgets, like the content of that text input, and I pack it up into a little structure. I've created a request sender when I first initialized the application, and that sender is running in the background, and I used a synchronous to an async queue here, or a channel, to communicate that send message request over to the background thread, which will then use the Matrix SDK. So this is a very common pattern you'll see because most SDKs seem to have adopted kind of an async only API, which is nice, but it's not great because I think most of these UI toolkits do not offer direct usage of async. And in any case, you don't want to do that on the main UI thread because you want to leave it open for the system to call platform-specific events and dispatch things to your main UI thread. So in any case, when we receive that request on an async worker thread, we then spawn a new async task that will actually handle the sending of the message. And this then uses the timeline.send or send reply function from the Matrix SDK, which can take a very long time depending on how how slow the home server is operating. Upwards of a minute or something. It depends. I've seen some very long timeouts. In any case, we do that asynchronously because it's I/O, so it makes sense. Then, how do we get the results of that sending operation back to the UI? For that, we have an action. So we post an action, which can then be observed by any widget throughout the entire system, or we can filter it up to us. And in this case, just like you saw in the previous slide where I had that event handling code, I have this event handling code for the room input bar, right? At which case, when I receive the action that indicates the message was sent or perhaps it failed, I can then go ahead and update my UI on the main UI thread. So that keeps us really, really nice and performant with no stutters. Oh, geez. And, okay. With no stutters and with no random hangs due to waiting on asynchronous events to happen from the main UI thread. Okay. So basically, this gives us a higher level look at this challenge is that we have a lot of mixed concurrency requests. Mixed concurrency contexts, right? Things that we must do on the main UI thread, for example, some platform-specific things, like when we're requesting the location, that has to be done from the main UI thread. And then things like I just showed, you just saw the Matrix async SDK. The Matrix SDK requires async requests to send a message. And then other things, we have miscellaneous things that may require running on an actual thread, not in an async context. And then, basically we have a bunch of different contexts that we're all dealing with. And the UI main thread is effectively responsible for just picking the latest, the latest state that is available for a given data binding or something. And we can pick it out of a cache, for example, for an image that we've retrieved from the Matrix Media SDK, Matrix Media API. All right, so we can do a whole bunch of different contexts like this, and then sort of blend them together with sync to async channels, and then actions going back to the UI. And then if we want to integrate the various feature abstractions that Robius offers, for example, querying current location or accessing the canonical directory for storage or cache on each platform, we can do that very easily, just like adding any other dependency on a Rust crate. So I've published some of these crates here under the Robius project moniker. And the code is really quite simple. So this is all it takes, for example, on the left to request the current location, and then you can send that to your UI via an action, just like I showed for the message send result. And then there's many, many more features, but I don't have time to get into them today. So that's basically where we're at with combining Makepad and Robius crates. And now I want to talk about sort of a different direction, which is something I've been working on for the last 6 weeks, so a relatively new project. This is the integration of the trust spanning protocol into Robrix, and basically running TSP over Matrix as a transport. So I'm sure most everyone is not familiar with TSP. Basically, it's a decentralized identity provider and verification framework and protocol. Right? So basically, it allows you to have trust relationships over an untrusted network, think the internet or something like that, where the underlying protocol, the spec, provides things like authenticity for a message. Basically, the sender of the message is indeed who they say they are. You verified that. And the contents of the message have not been tampered with. Confidentiality, right, which is in a similar vein, right, if you have chosen to encrypt the message, only the intended receiver can actually decrypt and view that message. And then it goes further. There's a lot more details, but one key aspect I'd like to highlight is metadata privacy, which is basically if you're sending your content through an untrusted intermediary server, like we show here on the upper part of this diagram, you're not leaking any information that could be used for like side channel attacks or something like that. So I am not an expert in TSP. I don't purport to know too much about it. But I was able to use the TSP SDK to support various features in Robrix that I'll highlight here in a second. Oh, geez. OK. One other key thing that I'd like to highlight is that unlike many other identity providers, think like a cloud single sign-on service like Google or Facebook or something like that, or Weixin's sign-on provider, we don't need a single central authority to act as the trust provider. The TSP SDK allows you to make that decentralized and still have a chain of history that allows you to autonomously prove you are who you are and that nobody else can impersonate you. Right? So the idea is that we create these long-term identities that persist in our local wallets. You can think of it as like your Apple Wallet or Google Wallet or WeChat Wallet. And then that's the ground truth right there. We don't actually need this to be authenticated or proven by a cloud identity like Google. So what does this look like in Robrix? So each one of the in systems is an instance of Robrix with TSP enabled. We have some very basic TSP test servers. Geez, I'm sorry for this. At these URLs here. And that's effectively how you can send a message to another TSP user without requiring something like peer-to-peer, although that is also supported. So this is just an easy way to do it. Right? It helps with discovery. And then we can use either TCP, HTTPS, or Matrix itself as a transport to send the underlying TSP messages. And then we have discoverers like services for discovery of other users, like the did.teaspoon.world. The way that we utilize TSP features is in public rooms, we can send non-confidential messages that have been signed but not encrypted. And then in private rooms, like a direct chat or something, you can actually fully encrypt the message, which sits on top of the Matrix protocol, so you can have something like double encryption. So what are the features that Robrix has implemented for TSP so far? We are able to create and manage wallets. We're able to create an identity. We're able to verify other identities and store that verified identity into your local wallet. We're able to associate that verified identity in your local wallet with a Matrix user ID. And I'll show you some demos of this. And then use that identity to sign a message so that other people can be assured of the non-tampered aspect and the authenticity of the message that was sent. So these are things that are unique to Robrix because they have an integration with Matrix. The other things are just something that the TSP SDK offers. But I believe I'm the first one to sort of implement a UI around them. So I have a basic video demo. Unfortunately, I can't do a live demo of this because it requires 2 machines and access to the TSP discovery services. So what I'm going to show here is, on the left, I have my personal Matrix account running on macOS. On the right, I have my test account running on Windows. What I'm going to do first is to create a new wallet Currently, this is basically just encrypted secure storage, but oh jeez, but you could integrate support and contact a local wallet like Apple or Google Wallet or something like that. Then I create a new identity and publish that onto the DID discovery server, and that allows me to basically say, hey, I would like to associate a particular user with their DID, the TSP DID. So I enter, from my personal account, I enter that, I don't know if you can see this, I enter the ID, and then I send a verification request to that instance of Robrix. If they accept it, then, there we go, then I've made that association, and then anytime, if I choose, I can sign a message sent, there you go, I'll move it up a little bit. I can sign a message that is sent, I can send a message using that ID to sign the message, and then receive that message on the other instance of Robrix via the matrix protocol. So this is just a regular matrix message. I'm not doing anything fancy here, right? So I've sent one signed message and one unsigned message, and then over here, you can see, I hope you can see that, on the right, I'm able to show a visual indicator as proof that this signature exists, right? So this is over the top of matrix. It doesn't require any extra features from the client, or from other clients. It plays nice with other clients. But I'll show you the content of what that looks like. And then in an effort to prevent other scams or other false identity issues, I can go ahead and do the same thing. I can do the same thing with a different identity. So let's say that somebody else was able to hack into my Matrix account and they created a different identity. Remember, they cannot create the same identity because those are persistent and they must be globally unique. So if I then create a different identity, let's say this is on a different machine, and I send a message with that identity and sign it, you'll see that the other client who's receiving that will check to see if the signature of that message matches the signature that they would expect that sender to have used, right? And here you can see it does not, right? So this is a really good way to offer an additional level of authenticity over an untrusted medium like a matrix account. So even if you had some hack or something went wrong with your matrix account in an unsecured manner, you could still rely on TSP to make sure that you're not getting duped into thinking that somebody else is sending you a message, and when it's really not them. So the way that this works is currently we sign the whole message and inject that signature directly into the message, and this is the spec-compliant way to do it. You can see that fourth field in the content struct is our TSP signature. The good thing about this is it doesn't affect any other clients. So if you don't have a TSP-enabled build of Robrix or use an Element or another matrix client, no problem, still works. So we have a lot of additional benefits. Like I said, I'm running out of time, so I'll go quickly. This is an additional layer of ID verification. We prove the identity and the message's authenticity. We can show a warning if someone's signature changes, which can prevent common false identity scams like pig butchering or shazhupan in Chinese. We can offer double encryption. So those first two things are done. The next thing I'm working on is offering double encryption for one-on-one direct messages in private rooms. So even if someone did compromise and verify your matrix account, they still wouldn't be able to read your encrypted history. The good thing about this is that identities are portable. So they're not tied to matrix, they're not limited to matrix. So if you have this whole network of relationships built up in your wallet, we can port that over and use it in other services, for example, Mastodon or Blue Sky or anything else that's federated. And then we can do other things like refer or endorse other users to a different user. For example, if you had a trusted contact, Bob, and you made a new friend, Alice, Bob could say, hey, this is indeed Alice, the one that you met, and they could use their entire relationship history to assert and prove that that is the case. Okay, so just wrapping up here. Main takeaway, you can now use Rust to build complex real-world applications. With Makepad and Robius, you can get high performance and you can have deep platform integration. There's still a lot of challenges that we're working on. Don't have time to get into them, but one of the major things is to make it easier to use because it is still, I think, a little bit more difficult to create a UI and handle the UX and the Rust logic than in other UI toolkits like React. And I want to push forward with more support for TSP and support things like the referrals I mentioned, nested relationships, which hide the fact that you even have a relationship, and double encryption. And then for more, feel free to check out our blog. Here's a roadmap. I'm going to skip that, but it's on that blog. I'd like to acknowledge the many folks who have helped make this work possible. Specifically, several folks here I think are in the audience on the right side here. And with that, I'll conclude and say, please reach out if you're interested. If you'd like to contribute, this is a link to our GitHub repository, and I will be happy to take any questions. Thank you.